Morning all, thank you for coming. Thank you for coming to the first talk of the morning, up nice and early. A few faces I recognise. I kind of have almost a traditional slot here, doing a slightly longer workshop for first thing in the morning. Those of you who have seen me speaking before may notice I've actually gone and got a proper job. I'm working for a company called Equals, and they paid for me to go to YAPSI in Riga, which is why the slides are branded for my employers. So hopefully you're all here to see me babble on for 50 minutes or so about measuring the quality of your Perl code. Just a quick summary of what we're going to talk about. Section 1, why on earth would I want to do this? Section 2, what shall I measure? Section 3, how am I going to do this? And then just a quick summary of how you're going to show off all the successes that you will no doubt have by following my 4-step plan. So we're going to start off, why on earth would you want to measure the quality of your Perl code? Not something that Perl programmers are traditionally known for caring about. Well, Peter Drucker is a well-known management consultant. So if you follow management consultancy people, you'll know his name. And he says, you can't manage what you can't measure. So unless you measure a quantity, you've got no real way of managing what's going on. To put that in a more technical way of thinking about it, we're talking about measuring something and then improving it, because in order to improve something, you need to have a baseline which you measure your improvements against. For example, it's the difference between somebody coming up to you and saying, oh, I made that database query faster, against them saying, I made that database query 25% faster. In order to quantify the improvements, you need to know what you started out with. And that second statement is hopefully more believable, more impressive than the first one. So we're talking about being able to quantify improvements that you make to the code. So it's a 3-step process. You measure, you improve, you measure again, you repeat. It's a 4-step process. It's a 6-step process. It's an iterative process. So what we need is a set of values that we can track over time in order to demonstrate the improvements in the quality of our code. Managers love all that kind of stuff. I mean, imagine being able to show your manager a graph that looks something like that. That's going to make them a very happy person. Okay, so hopefully I've persuaded you that it's worth taking the effort to do this, to measure the quality of your code. Next step, what the hell are we going to measure? So in order to draw that kind of graph that was a couple of slides back, well, we need dates. And we need numbers. Dates are easy, well, unless you're London Perlmongers who have traditionally had a problem with dates of things. But dates are generally seen as easy. You just call the now function or something like that. So what numbers can we use to measure the quality of our Perl code? Well, whilst writing this talk, I did quite a lot of research into this, and I came up with, there are no numbers which accurately and directly measure the quality of your Perl code. So I'm sorry for getting you out of bed so early, completely wasted your time. The canteen is still serving. Well, no. So what we need to do instead is we need to measure proxies. Proxies, Dave, I hear you say. What are they? Well, I'm glad you asked, because I'm going to answer. I asked Wikipedia. So in statistics, a proxy is a variable that is not in itself directly relevant, but which serves in place of an unobservable or immeasurable variable. So we've already established, or I've told you, that the quality of your Perl code is not measurable, so we need to find a proxy, or more than one proxy value that can stand in place of the quality of your code. Moving on in the definition, in order for the variable to be a good proxy, it must have a close correlation with the value that you're trying to measure. That measure doesn't have to be linear, and it could be positive or negative. So it could be something that exponentially goes up when your code gets better, and it could be something that goes down as your code gets better. And we'll see examples of all of these things. So I'm going to propose 4 proxy measures that we can use to measure to kind of measure the quality of our Perl code. We have test passes, test coverage, Perl critic scores, and cyclomatic complexity. I gave this talk, as I mentioned, in Riga in August, and 2 days before I gave the talk, Curtis Poe stood up and gave a talk in the biggest room where he completely destroyed the idea that cyclomatic complexity is of any use whatsoever in measuring the quality of code. But I soldier on regardless. So just to look at those 4 values in a little bit more data. So test passes. I think this is kind of obvious, isn't it? That code that passes its test suite is presumably better than code that doesn't. That follows, doesn't it? Secondly, test coverage. It's getting slightly more contentious here. Code with a test suite that covers more of the code is likely to be better than code that, with less test coverage. On slightly shaky ground here, code that conforms to some arbitrary set of best practices is better than code that doesn't. But the important thing here is, when we're talking about Perl critic, what some people don't seem to realize is you don't need to use Perl critic as it is out of the box. You can configure it to measure your own set of coding standards. You can turn things off, you can add extra things. So decide what the quality of your code should look like, and then implement Perl critic in a way that measures that. And finally, cyclomatic complexity, because simple code is likely to contain fewer bugs than complex code. As I said, Curtis Poe will argue with that, but I still think it's worth measuring. Some people might not be familiar with the concept of cyclomatic complexity, so just to dig into that a little bit more, basically what we're doing is measuring the complexity of your code. You do that by basically counting the branching points in the code. So code that's got loads of ifs and loops and things like that is more complex than code that just goes straight statement. If you want to find out more about this, there's a module on CPAN called Perl Metrics Simple, and I wrote a Perl Advent Calendar article about it back in 2014, and nothing much has changed in the 5 years since then. But just to show you one thing, the Perl Metrics Simple will give you a HTML page output of the complexity scores of your code, and it color codes it, and it has a little key which tells you the kind of numbers that you should expect to be seeing. And this is the key. So, under 10 is the kind of numbers that you'd love to be seeing. If all of my code was under 10, I'd be very happy. Seeing 10 and 20, it's tapping you on the shoulder saying, by the way, you might want to have a look at this. Over 20, and we're like, WTF. And then the first time that I actually ran this against a client's code base, and I will not tell you which client this is, there were modules that came out with complexity scores in the hundreds. But then, you know that this code is bad when you look at a subroutine and it's 300 lines of code in a single sub. Okay, so I know that all of these measurements are potentially contentious. You can argue most of them, but the point is just, but that's why they're proxies. That's why we know we are not measuring the quality of the code. We're just measuring something that looks a lot like the quality of the code. And if you don't like those 4 numbers, then find other numbers that you like. Okay, so we've done the what, we've done the why. Next we come to the question of how. So what we want to do is we want to measure each of these proxy values on a regular basis. What do you mean by regular basis? Well, maybe for that graph to show your manager, perhaps measuring it weekly would be enough, just to show a gradual creeping upwards of the quality of your code base. Maybe within the team, doing it daily would make more sense, so you can actually see if something that you did yesterday was really stupid. It happens. Or maybe we can do it on every commit. Every time you check code into the code base, you do something that measures the quality of the code. Taking it even further, maybe you could do something like in a pre-commit hook, run the code and stop somebody from committing code that lowers the quality of your code base. I haven't actually ever done that, but I'm just thinking aloud here. But the important thing is we need to be able to do this automatically. We want to set something up so that we can just set it up and forget about it, and it will just carry on working. If this has a manual step in it, then you can guarantee that at some point that won't get done. So we make as much of this as possible completely automatic. And that sounds like continuous integration. Some of you may not have come across continuous integration yet. Basically, what we've got is a system that monitors your source code repository and will take various actions in response to various events. That's very waffly. What the hell do I mean by that? So there are 3 quite well-known continuous integration environments: Jenkins, Travis CI, and Circle CI. Jenkins probably has the lion's share of the marketplace at the moment. Yeah. Sure. I mean, there are plenty of others. In fact, probably on the day that I gave this talk in Riga, I got an email from GitHub saying that they've introduced GitHub Actions, which will do a lot of this stuff. So maybe I should think about integrating that into this talk. Yeah. There's loads of things. So, but basically, you've got a tool, and it could be any of these dozens of tools, and it will allow you to set up rules that say things like, when code is committed to any branch, run this task against that branch. Each Sunday at 2 a.m. in the morning, run this task. When code is merged to the release branch, run these tests. Where task, in inverted commas, means basically anything that you can write a script for. You can run tests. You can send an email to someone. You can build a new Docker image, deploy that to a staging environment, run tests against it, and if the tests all pass, email someone asking them to approve a release to production. You may have heard of a company called Netflix. I hear they're quite famous amongst the young people. They do multiple releases into production every day. And when I say multiple releases, I'm talking dozens, if not hundreds, of releases into production, because each of them is tiny and they have a continuous integration pipeline. They don't have this email someone asking them to approve a release into production step. Their production pipeline just moves stuff into production. But the testing that they do is, the automatic testing that they do is pretty good. But anyway, so all this means that continuous integration is pretty much perfect for our requirements. So what it looks like for us is every time code is committed, you run a series of scripts that measures the proxies and records those values in a database against a timestamp. And then you've got dates, you've got numbers, you can draw graphs. Sounds easy, right? Yeah, and plot a graph at the end. Email it to your manager. Look, we're doing well. Give me a pay rise. It's all just a simple matter of programming. But don't do that. Don't do that because it's such a useful idea. People have already written these things. So taking Travis CI as an example, only because it's what I use to do work like this against most of my GitHub repos. Other CI systems are available, of course. So what you do is you go to Travis CI, you sign up with your GitHub account. It probably supports GitLab and Bitbucket and other options. It will go to GitHub and pull in a list of all of your repos, and you go down and you tick the ones that you want to Travis CI to work on. Then you need to, back in your Git repository, you add a file called .travis.yaml. And really, all it needs to include is tell Travis that it's that you're dealing with Perl, and list the versions of Perl that you're using. Should have added Perl 5.30 to. And then the next time you commit something to your GitHub repo, Travis will recognize that's happened, and it will follow the instructions in your .travis.yaml, and some small number of minutes later, in your Travis account, you will see something like this. And obviously, I've chosen one that's green, because why would I want you to think that my code ever fails its tests? And so basically, what's happened here is GitHub is that Travis CI has spotted the new commit, it has checked out the repo, and it has run your tests and taken the output from those tests, stored them in its database, and then is giving you a summary saying, so you've got all the different versions of Perl that it ran it against, and they're all green with ticks. You can click on any of these, and it will show you the logs of the run. So you have all your tests passing, and you have an easy view of your tests. So going back to our list of the 4 proxies, we can tick the first one because we've managed to do that relatively easily. But it gets better, because there's another system that people have written called Coveralls.io. And Coveralls.io measures test coverage. Is there anyone that's not really clear on what test coverage is? I realise that I'm just been waffling about it, and maybe there are people that don't quite understand. What we're basically talking about is running your test suite, and every time taking careful note of what is executed while your test suite is running, and every time a statement is executed, writing down in the database which statement got executed. And when there's a branching point, writing down whether that was true or false. and then producing a report saying that your test suite exercises 85% of your code. Obviously, you'd like to aim for something in the high 90s, so that all of your code, you know that all of your code gets run. Because code that doesn't get run during the test suite is code where bugs can hide. So Coveralls reports on test coverage. Again, sign up with your GitHub account, and presumably it supports GitLab, Bitbucket, all those other good things. Very similar to Travis CI. It'll pull in all the repos that you have access to. It gives you a list. You tick the ones that you want to work on. You need to add something to your Travis CL, Travis YAML. We're adding instructions to install a module from CPAN called devel cover report coveralls, and then script. So Travis CI knows how to test Perl code. It knows to look for either a build.pl or a makefile.pl and run through all the tests. If you give it a script key in your YAML file, it's saying, instead of doing the automatic thing that I know you know how to do this instead. And because we need to do a slightly more complicated version, we need to run this cover command. And the report option to the cover command tells devel cover, tells the cover command to produce the report in a format which coveralls.io knows about, which will be some kind of JSON, and then to make an API call to Coveralls, squirting that information over to Coveralls. What I haven't mentioned, I realize, is we are relying here on devel cover, which is a pretty well-known CPAN module which does all of the coverage testing for you. When I gave this talk in Riga, Paul Johnson, who is the author of devel cover, was sitting in the audience. Always nice to have people who wrote the tools you're talking about sitting in the audience, because it puts you under no pressure whatsoever. And he did actually point out that there's the standard devel cover reports produce coverage reports at a far more granular level than Coveralls does. So you get more information if you don't use Coveralls, but then you have to write your own system to do the measurements or to do the tracking of the measurements, whereas Coveralls use a little bit, you lose a little bit of granularity, but it does it all for you. So yeah, so we set up the script tag in our travis.yaml so that we call the cover command, and that pushes our reports to coveralls.io. And then the next time you go to your Coveralls page, you will see another run has been added to the page for that module. And it's got a headline in the badge that says coverage is 97%, because obviously all of my CPAN modules has test coverage in that kind of range. And then what I think it's quite nice is there's this like a spark line as a background image of the graph over time. So you can see that something went wrong here. Not entirely sure what. Probably I don't think it was a bug in the test. I think the test just didn't get run for some reason. Oh, and also it says here, you may not be able to see it from where you're sitting, but it tells you that the changes in the coverage between this run and the previous run. So you know whether you're getting better or worse. So for proxies, we've already ticked test passes, and now we can tick test coverage as well. So moving on to the next one, which is Perl Critic. Perl Critic, there's a website out there called Kritika.io, which is written by a Perl hacker who I only know as VTI, but he's very helpful. I've exchanged quite a lot of Twitter messages with him to get patches added to his system. And you'll be getting bored of this sequence of events now. Go to Kritika, you sign up with your GitHub account or whatever the other repo host you use, and it will go and drag in all your repos and ask you which ones you want to cover. And then the next time you push a commit, it will do the testing stuff with Travis CI, it will do the testing coverage stuff with Coveralls.io, but you'll also get information on the Kritika webpage. And the way that Kritika works is it gives you a grade. So you're aiming for grade A code or B plus or something like that. At the top, you'll see it's tested 18 files. That there's one Kritika violation in one of those files. So you could click on that and it would tell you which file, and it would show you the code, and it would even show you which line in the code has the problem that you need to go and fix. It shows you a map here, a graph of the number of violations over time, and so it seems that that one violation that I've had forever is not an important one. It's not critical because I've got 0 critical violations. But Kritika also measures complexity. So actually you get 2 for 1. It handles both of them at the same time. And so here you can see that the complexity of this code, and I think what it's showing you here is actually, so complexity is measured on a file-by-file basis, and this is the maximum complexity of any of my files. So if you think back to the key of complexity values that we saw earlier, I'm just hovering on the border between the FYI and the BTW version. Yeah. So if I was feeling bored, I might go and say, well, how can I make some of these subroutines less complicated? But at 10, I'm reasonably happy. I had some of you may have seen my CPAN module symbol approx sub, which allows you to call subroutines even if you spell the names wrong. And funnily enough, some of the code in that had some quite high complexity values. But actually, I spent a very enjoyable weekend hacking away on it because it was code I hadn't looked at for a long time, making it all much simpler. I think there's a file in there now that's got a complexity of 12 or something, so I might revisit it at some point. But so it's now much simpler to understand how I do incredibly stupid things in that module. So yes, we can tick Perl Critic, and we can tick Cyclomatic Complexity. So we found helpful people out there in the world who have written systems that allow us to measure the proxies for the quality of our Perl code. And we haven't had to write a single line of code, which is always a bonus. Okay, I've got 20 minutes left, so I'm going to have time to take some questions at the end. How do we summarize this? So this is about finding good ways to display the successes that you've had. So I showed that graph at the end, at the start of the talk. How do we achieve something similar to that? Well, everyone likes badges. If you were looking at the output from Travis and Coveralls, you'll see these things tend to have the very common style of badge. Badges are cool. You've seen this kind of thing appearing all over the place. And all of these services will generate badges for you. So in Travis CI, you have a build passing or a build failing, or there's a couple of other error conditions when it hasn't been able to run your test suite for some reason. Coveralls will helpfully show the amount of coverage, the level of coverage in your code. And I should point out, obviously the color green goes away and it becomes red when it's failing. And Coveralls has a scale of different colors. I think it gets to green when your coverage gets to about 95% or something like that. And then it's orange and red further down. Kritika will give you a grade badge. Actually, it doesn't have one for complexity yet. So maybe that's something I'll suggest to VTI. People sometimes like to put their badges on their CPAN pages. So here's an example from IO_all, one of Inge's modules, just saying that his build is passing. And most of these systems will helpfully have a thing where if you look on their web page and you see a badge, if you right-click on the badge, it will give you a pop-up where it gives you the code that you need to just cut and paste to embed it in your website. Or another common place to put them is in the READMEs in the GitHub repo. So I've got fewer CPAN modules than I used to have, because I keep giving them all to Mohammed to look after, because I'm lazy and he's not. But what I wanted was a status page that would show me these badges for all of my CPAN modules. Just for those rainy Sunday afternoons where you're thinking, there's really nothing very good on telly. I fancy some hacking. I don't have a project that I'm actually working on at the moment. Let's have a look at the quality or the test coverage of my CPAN modules. Find somewhere likely where I can improve something. And this is what led to the weekend of hacking on the symbol approx sub code. What I wanted was something that looks like this, that sits at code.perlhacks.com. And I've actually added another badge here. This is showing you the CPAN version number, the current version on CPAN. And again, that changes color. The blue ones are things that are at version 1 point something at least. So the ones that are orange are the ones that still look like they're in beta or something like that. So I probably just want to do another release, because I think I'm pretty happy with the condition of all of them. I've got build passing on all of them. And I should point out that when I knew I was going to be producing this slide, that led to a couple of weekends of hacking on the code, because I did have, there's some, you can see my audio file distributions there, and they need ogg vorbis libraries. So it took a bit of hacking to get the ogg vorbis or the MP3 libraries installed on the Docker container that Travis CI uses to run the tests. So I had to spend some time working out. So I had all green to show people at the talks. Test coverage, doing all right. I know that actually this is only the first half of the screen, and lower down I've got at least one module that has it's on CPAN, but it has a test coverage. It has a test coverage of 4%. So more work needed there. And then Kritika, I try to keep all my Kritika grades at least A. The code for this is on GitHub. It's called Dashboard, so github.com/dashboard, GitHub dashboard. And I would love for other people to download it, use it. Basically, it's a YAML file, and then there's it's 2 stages. So there's a YAML file, and then a script that you run, which generates an HTML page which contains all of your modules. But all of the actual badges are JavaScript calls to remote servers or just embedded images that you load from a remote server. So once you've generated the dashboard, you can just leave that page on a website somewhere, and it will automatically update every time someone visits it. The only time you need to rerun to regenerate it is if you want to add another module to the list. But obviously you could, I mean, it works out the list by making a call to the Meta CPAN API, so you could probably wrap that up so that it does that every time somebody visits the page. But I would love to see other people using it. And when I gave the talk in Riga, about 3 people came up to me and said, oh, that's really cool, I'm going to try that. But I've not seen any examples of it yet. So please do. So in conclusion, why do we want to do this? Well, we want to do it in order to quantify the improvements that we've made to our code. What do we do? Well, we can't actually directly measure the quality of our Perl code. That's because it's just an amorphous, undefined value. So we find proxy measures. The proxy measures that we use are, that I use are test passes, test coverage, test critic figures, and cyclomatic complexity. We use continuous integration to automate the process. Mine's all driven from Travis CI or from other services. And to summarize, we display badges because, well, badges are cool, as we've established. And please have a go at using my dashboard to do similar for your code. I've missed something out in the talk because that would be another day's worth of actually doing the work to improve the code is left for you. But I would be fascinated to hear any war stories that you have about how successful. I think I'm particularly interested to hear about people who measured the complexity of their code, panicked, hacked away a lot, and then came back 3 weeks later with code that was actually far easier to understand. Right, well, thank you for listening. And one thing I've learned at these, the London Perl Workshop is if you let people out of your talk 2 minutes early, so they get to the front of the queue for whatever the food is, then they give you better ratings. Sorry? That means, yeah, it might look like we've got 10 minutes, but no, I'm going to give you 8 minutes if anyone's got any questions. Oh, we have a microphone. Wow. It means I don't have to repeat the question.
All these songs you gave on measuring those things were present-oriented. How easy is it to generate historical data using those things? Do any of those services go ahead in time, or are they always...
Oh, that's interesting. So what you're saying is, obviously GitHub has a history of my repo. Can I point Travis CI at the repo and say, I don't believe any of them do that, but now I'm thinking, I'm thinking go to Neil's talk after this. But I'm also thinking you could perhaps set up a copy repo and push the commits into the copy repo one at a time, maybe. Oh, Neil.
What on earth do you do to get 4% test coverage?
You write minimal tests.
Use OK.
Yeah, use OK. So I have a few silly modules on CPAN. The one with 4% test coverage is not a silly module. It's it's for people who deal with QMail, so it might be considered as a silly module by some people. But one of the silliest modules I have on CPAN is called tie-hash cannabinol, because it's THC. So it's a tied hash which forgets things. And originally it had the most minimal test suite ever. But back in the days when at YAPC we used to have auctions for useful and interesting things, I won a YAPC auction for Michael Schwern to improve the test suite of one of my CPAN modules, and I handed him tie-hash cannabinol. And he actually came up with a mechanism for testing stuff, and the test coverage leapt up to about 80% or something. Any other questions? Oh, a couple more down here. Mohammed's going to ask if he can take over more of my modules. Well, I mean, I guess if you're working under a TDD approach, then your test coverage is always going to be pretty good. But, well, yeah, I mean, I guess in that situation, you might not put so much store by the test coverage, but you're still interested in test. Well, again, test passes maybe, because you're not going to commit anything where the tests don't pass. Well, hopefully, nobody commits things where the tests don't pass. But you've still got two measures that could be useful, and maybe you can come up with other ones. Mohammed.
One thing I'm missing in your talk was about quality with K. What do you think about it? Do you think it can be one of the proxy?
Yes. So for those of you that don't know, many years ago, again, it might have originally been set up by Michael Schwern. The quality service, where quality is spelt with a KW rather than a QU at the start, on the basis that quality of a module is not something you can actually measure, which I agree with, obviously, but quality with a KW is something that looks a bit like quality and can stand in for quality in some circumstances. So quality with a KW is actually a proxy measure. And there is something called CPANTS, CPAN testing service. And every time a module is uploaded to CPAN, it downloads it and runs quality KW tests against it and gives your module a quality score. So yes, you can use the quality number, which is a percentage. You can use that as a proxy by all means. And I'm pretty sure that the current incarnation of the CPANTS quality measuring service has an API that you could use to feed into a system like this. If it doesn't have a badge system, it would be the work of an afternoon to hack one together. So yes, the only downside I can see to it is that it works directly from uploads to CPAN. So if you're not all of the things that I use my mechanism for are uploaded to CPAN, because I write code that is not all CPAN modules. There's one more at the front before we come back to you.
That's Critic site that you mentioned.
Kritika.io.
Yes. Does that use Devin Conway's list of rules, or does that?
By default, it seems to use an out-of-the-box Perl Critic, but I should have mentioned this. It has a setup where you can actually turn things. I think you can turn things off. I think it might be harder to add your own stuff, but you can certainly turn some of the rules off if they're annoying to you. Honestly, answer to that, I don't know. I'm not clever enough to have a Perl Critic RC in any of my libraries.
The other thing I was going to mention is that I think quality of K is like generally sort of CPAN oriented.
Yes.
As opposed to like code quality oriented is to do with quality of model, quality of code.
Oh, because, yes. I mean, a lot of the scores there are things like whether your CPAN module is packaged well. It's got all the right things that a CPAN module expects to see, like license files, and whether the make file's got all the right information in, which is probably not the kind of quality that we're talking about measuring with the other things. If anyone's looking for a topic for a research paper, that sounds like a fascinating idea. And to help you with that, I can't remember who did it, but a few years ago, somebody took the history of all of the releases. I mean, I know most of us who have CPAN modules will be storing the code on GitHub or something like that. But not everyone does, and not all of the CPAN modules that are still on CPAN have been updated in the last 10 years. So what somebody did was that they downloaded all of the tarballs, because all of the stuff that's not on CPAN is still on backpan, and created a CPAN repo on GitHub which has a new commit for every release of every CPAN module, so that you could use that for input even on the modules that don't have their own GitHub history. I think we're out of time, and you might just not be quite at the front of the queue for whatever the goodies are down at the thing. So I can just say thank you very much for listening. Hope it's been useful. Please use my dashboard, and if you have any further questions, I'll be here all day. Feel free to stop me in the hallway. Thank you very much.